Today, we're going to carry on from our tutorial last lesson and talk about how to differentiate the polynomial we created. Now, what is interesting when you look at the code I've done in comparison to the code for setting up the polynomial is that the only real differences are these two lines, the print line and the gradient list line. And one thing I've noticed among younger mathematicians and younger coders who are very, very excited to do coding, very excited to do the maths, is that they try to make things complicated. And the reason with that is that, you want to show how clever you are. You want to show that you can create all these clever routines using all this advanced mathematics. The advice I'll give to people is don't be a hero. You don't need to create a whole differentiation routine from scratch. You can use what Python already has, and that's a skill of a good coder, is making the code as efficient and user-friendly as possible while still getting the outcome you desire. So, if we have a look at this, I've only added 3 lines, as I mentioned earlier. Now let's talk about those. Well, firstly, if I'm going to differentiate, I want an actual answer for my derivative. So if my polynomial is a list of terms, then my gradient function will also be a list of terms, my differentiated function. And let's now move on to what this means. So we have the word diff. Diff means to differentiate, well, which makes sense, right? So again, we don't need to create a whole routine to differentiate because Python did that for us. What we need to do is to make sure that Python understands what we're feeding it. So let's run the code and debug, and we'll talk about each part of the code. Now, we'll start as we did earlier, how many terms of the polynomial we have. So we'll do a 3-term polynomial, and then we'll debug each line. So please input term coefficient. So let's just make up, let's say 3, and then we'll move on to the term index. So let's say 3 there. And the symbols that we talked about already. So you can already see here, we're generating code like we did last time. Now I talked about the symbols in the last tutorial. And we talked about the insert command. So I is equal to 0. So that's going to insert the term into the first row, like we talked about last tutorial. Now, let's talk about this command, the differentiation. So term is what we're feeding in. So we're feeding into the first part, our term 3t to the power of 3. And the symbols command is because, again, we want Python to be able to read what we're doing. So we're telling Python that it's a symbol rather than a variable, because then it will actually do the differentiation. But then our next part, we do that. And you can see here, we've actually differentiated it. 3t cubed, if we differentiate, is 9t squared. So that's pretty cool, right? And again, no complicated lines of code creating our own routine. Now, like before, we need to insert. So for our polynomial, we inserted term into there, and I being the ith location. So I is equal to 0 is the first location. What we've done there for the grad insert is replace the gradient, because we've called it grad, and we've inserted our derivative. So we'll carry on from there. So let's input another term coefficient. Let's do a negative, and then you know what? Let's even do a negative power. So let's say -7. Okay. And from there, we can see now it's got the derivative. So we end up with 14, 0. What's interesting here is rather than writing it as an indice, they've written it as 14 over t to the power of 8, rather than 14 times t to the power of -8. And then same principle, we're going to insert it. And there we go, we have our second term. And then we'll carry on with there. You know what? Let's add a 3. And I'm going to say the power is going to equal 0. So 3 to the power of 0. So it's going to be a constant. And let's see if our derivative will work in that regard. What we hope will happen is if I differentiate a constant, it's going to give me 0. Let's find out. And it gives me 0. And we substitute in it, and there we have our derivative. And what we're going to do, the code is finished because it's run through 3 times. We're going to print out, and job's done. We get our derivative. Next time, we're going to actually get exact values of the derivatives at particular points. See you there.